Hey guys, Ms. Fearing here. Welcome to Unit 4 Notes 4. We're going to look at some special case factoring. So in the previous lessons, we've been using the X method for factoring or the guess and check method. You can use both of those methods on these examples as well, but these are considered special cases and there is a faster way to kind of go through doing it. So again, you can choose if you want to continue using the X method, go for it. Otherwise, we're going to look at some different ways of factoring some special cases. So the first example we're going to look at here is our difference of squares. So remember, we're in standard form with ax squared plus bx plus c. So in our difference of squares, the b value ends up being a 0. It's not there, so we don't have any x's. And then our c value ends up being a negative number. So that's where it comes from the difference, because you're ending up having two pieces or two terms that you are subtracting. Here's what we're looking for to tell if this is a difference of squares. Our a value and our c value in all of these special cases need to be perfect squares. And what I mean when I'm saying that is it needs to be a number times itself. So it could be 2 times 2, which means 4 is a perfect square, or 3 times 3, which means 9 is a perfect square. So basically, perfect squares are anything you can take the square root of. And the way that this is going to work is when we put it in factored form, the square root of the ax, is going to be in the first spot, and then the square root of the c is going to be in the second spot, and then one will be a plus and one will be a minus if we're dealing with difference of squares. So let's go ahead and look at our first example here. We want to see we do have two terms that are being subtracted, so this is a difference of squares. And we always want to go through the same steps. So step number 1, is there a GCF that I can take out? In our first example, there is not. So then step number 2, I want to see, can I take the square root of the a and the c to do this factoring in a fast way? Well, remember the a in this situation is a 1, and I know that this can be factored into 1n times 1n, so it's a number times itself. And then 25 is actually going to be 5 times 5. So these are both perfect squares. So I can go straight into factoring really fast here. I know that one's going to be a plus and one's going to be a minus. My first term is going to be 1n and 1n. And my second term is going to be 5 and 5. Now, this would be my final answer, but you can always go through and double check by foiling this back out and seeing if it gets you back up to the top. So I can do 1n times 1n, so I get 1n squared. 1n times a negative 5 gives me negative 5n. 5 times a 1n gives me a plus 5n. And then 5 times negative 5 gives me negative 25. Combine these two, a negative plus a positive. They cancel out, so I get 1n squared minus 25, which is exactly where I started from, so I know I'm on the right track. So again, looking at example number 2 here, first thing I want to look for, is there a GCF that they both have that I can take out? In this situation, there is not. So second thing I want to see, are the a and the c values both perfect squares where I can take the square root and do special case factoring? And in this situation, I know that 36x squared can be written as a 6x times a 6x. And then a 49y squared can be written as a 7y times a 7y. So I'm going to go ahead and set up my factors. This is a difference of squares. It's a special case. So I'm going to have a 6x and a 6x. I'm going to have a 7y and a 7y. And because that b value is a 0, it's not there, I know that I need 1 to be a plus and 1 to be a minus. So example number 3 here, let's go ahead and go through our steps. First step we look for always is a GCF. Is there a GCF I can take out? In this situation, there is. 12 goes into both of them, and an a is in both of them. So I'm going to divide each thing by 12a, which means I'm going to be left with 12a times 4a squared minus 1. So now I'm going to go ahead and I'm just going to look at what's inside the parentheses and see if I can factor that even further here. In this situation, I already took the GCF out. Now let's see, if the A and the C are perfect squares, then I can go ahead and do my fast factoring. So I know that I can take the square root of 4 and get 2A times 2A. And then the 1 can be written as 1 times 1. So I can use this as a special case factoring. So I know that my first term is going to be a 2A and a 2A. And my second term is going to be a 1 and a 1. And because I want that middle term to cancel out, I need a plus and a minus. I want you to go ahead and try number 4 on your own. Remember, go through your steps. Is there a GCF that you can take out? If there isn't, then your next step are the A and the C perfect squares. Can you do a fast factoring with this? If that doesn't work, then you can go into your X method. So pause the video, try it, and then come back and check your answer. So here's what I got when I went through and did this problem. And as I was working through this problem, I remembered something that I forgot to talk to you about on example number 3. So anytime you take out some sort of GCF, you have to remember that that needs to be put back in your final answer. So it's basically like you took your sister out to the mall. You have to make sure you bring her back home. Otherwise, your parents are going to be pretty upset. So make sure that your sister is always taken along with you on your ride back home. So this 12A that I took out in the beginning really should be down here in front as well in my final answer. So that would be my final answer for 3. If you got something different for number 4, please come talk to me before moving on in the video, and for sure before moving on in the practice. So now we're going to change it up just a little bit. We're going to talk about perfect square trinomials. So basically, you're going to be in the form ax squared plus bx plus c. You will have an a, a b, and a c in this situation. Your a and your c are still going to be perfect squares. So that's what you're looking for. Basically, then the middle term, that bx, if it's a positive, then both of your signs are going to be plus signs. If it's a minus or a negative b, then both of your signs in your factored form are going to be negatives. So let's go ahead and look at some examples for that. Number 5 then, I want to go ahead and I'm going to go through my steps. Is there a GCF that I can take out? In this situation, they all don't have something in common, so I can't do that. So the next thing I'm going to look for is the A value and the C value, are these perfect squares? Remember, that's a 1 there, which I know I can rewrite that as 1n times 1n. And then 144, I know I can write as 12 times 12. And remember, if you can't figure that out, you can always try taking the square root of it in your calculator and seeing if it gives you a whole number. So in this situation, it is going to be a perfect squares. I know that my first number is going to be a 1n and a 1n. And my second term is going to be a 12 and a 12. Now, to determine the sign, we look at the middle term. Since this is a negative, I know that both of my signs need to be subtraction signs. So you can write your answer this way, or since I have 2 of the exact same thing, I can write it as 1n minus 12 squared as well. So example number 6 here then, again, go through your steps. Is there a GCF that I can take out? In this situation, there is not. So now I'm going to go to, is A and C, are those perfect squares? They are. I know that I can rewrite a 9y squared as a 3y times a 3y, and a 4 as a 2 and a 2. So in my factors, I'm going to have 3y and 3y, and I'm going to have 2 and 2. And then again, we want to look at that middle term. Since that middle term is a minus, I know that both of these need to be minuses. So that's going to be my final answer. Or, again, since I have 2 of the exact same thing, I can rewrite it as 3y minus 2 squared. Example number 7 here, again, go through those steps. Those steps should be always your second nature of where you start from. So is there a GCF that I can take out? Yes, in this problem there is. There is a 2 that I can take out of everything. So I'm going to have 2 times 9y squared plus 24y plus 16. So now I want to look at the inside of the parentheses. I'm going to pretend like that my little sister isn't at the mall with me, and we're just going to factor what's inside the parentheses. So we're going to see, is this a special case? The a, I can go ahead and I can take the square root of the a by doing a 3y and a 3y. So 3y times 3y. And the 16, I know I can rewrite as 4 times 4. So this is a special case. So I'm going to have a 3y and a 3y. And then a 4 and a 4 is my second term. And now again, look at that middle term there. That middle term tells me what my signs are. So since it's a positive, these both need to be positives for me. So I can rewrite this with my little sister out front because I don't want to forget her. And then that would be my final answer. Or if you like to shorten it down, I have 2 times 3y plus 4 squared. Again, either answer would be correct, but don't forget that you need to bring your sister home. Go ahead and pause the video, try number 8, go through your steps, and then come back and check your answer. So here's what I got for my answer. Don't forget that you should have brought that 2 with you at the end, and that either of these answers is a correct answer. It's just up to you on how you want to rewrite it in the end. So here's the last situation that could happen. Remember, your steps you have to go through checking for a GCF first. If there is no GCF, then we go and we want to determine, is this a special case? Can I take the square root of the a and the c? If you can, go ahead and factor that way. If you can't, then you want to go and check your x method. Can I go and solve it using that x where I multiply to the a times c and add to the b? If you can't do that, then you might have a relatively prime expression. So if you have that, you can go ahead and just write relatively prime. So let's look at example number 11 here. So I want to see, do I have a GCF? And in this situation, these terms do not all have something in common, so there's no GCF. So now I want to see, is the a and the c a perfect square? Can I take the square root of both of them? In this situation, I can. I have a 1x and a 1x, and then a 3 and a 3. Now here's where we have to actually be really careful, and we haven't been checking this, but since that middle term is a plus, we know it need to be pluses. If I go back through and I factor this out, or FOIL this out, I get 1x squared plus 3x plus 3x plus 9. So if I reduce that down, I get 1x squared plus 6x plus 9, which is not the same exact thing as what I started with. So in this situation, I can factor it, but it doesn't get me back to where I started from. So I know that this is going to be a relatively prime example then. So I can write relatively prime and be done. So example number 12, we want to go ahead and go through our steps. So first step is there a GCF? And there's a 5 in this situation. So I'm going to have 5 times x squared plus 2x plus 2. And now I want to check, is this a special case? Can I take the square root of the a and the c? I can take the square root of 1, but I can't take the square root of 2. So this is not going to be a special case factoring. So the next thing I want to check is, can I factor using the x? So we multiply the a times the c to get to the top and the b to get to the bottom. So I'm looking for 2 numbers that multiply to 2 and add to 2. Well, my only factors are 2 or 1 and 2, and they multiply, but they don't add. So again, this is going to be a relatively prime example. I cannot factor this right now. Go ahead and practice the examples. Make sure you check in with me if you have any questions before moving forward.